Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us learn how to solve the problem on angle between the direction of the given surface with respect to two set of function. That is one x square plus y square plus z square equal to 9 and z equal to x square plus y square minus 3 at the points 2 comma minus 1 comma 2. How to reduce and how to simplify? Now let us see find the what angle between the direction of the surface. First, we are going to represent the given conditions or the equations, that is given. Okay, first let us define what is angle between the surface. Angle between the surface is given by cos theta, which is equal to n1 cap into n2 cap, where n1 cap defines gradient phi1 divided by modulus of gradient phi1 and n2 cap defines gradient phi2 divided by modulus of gradient phi2. Done. Now we need to define the scalar function with respect to phi1 and phi2. How? First let us see. Let us consider the given. First given, that is x square plus y square plus z square equal to 9, and the another condition is z equal to x square plus y square minus 3. To define phi, the scalar function phi, the equation should be defined with respect to equal to 0. So what we are going to do, I am going to shift from RHS to LHS part. X square plus y square plus z square minus 9 equal to 0. Similarly, x square plus y square minus z minus 3 equal to 0. Now, this one equation I am going to represent it as phi1, that is x square plus y square plus z square minus 9, and this I am going to represent it as phi2, which is equal to x square plus y square minus z minus 3. Done. Now let us find first n1 cap. What is our n1 cap? Consider n1 cap where gradient phi1 divided by modulus of gradient phi1. What does gradient phi1 defines? Gradient phi1 defines dou phi1 by dou x I cap plus dou phi1 divided by dou y j cap plus dou phi1 divided by dou z k cap. That means I need to differentiate the scalar function phi1 with respect to variable, that is x, y, z with respect to the direction I, j, k. Now let us differentiate, that is gradient phi1, which is equal to dou by dou x into what is phi1? We have x square plus y square plus z square minus 9 I cap plus dou by dou y into x square plus y square plus z square minus 9 plus dou by dou z into x square plus y square plus z square minus 9. Now, I am going to differentiate this whole term with respect to x, y and z. First, let us differentiate this whole term with respect to x. Let us differentiate term by term. That is gradient phi1, which is equal to differentiation of x square. We have only x square. Differentiation of x square with respect to x is 2x plus. In the second term, we don't have variable x, so second term becomes 0. Plus in the third term we don't have x, so this also becomes 0, minus differentiation of constant term is 0 into I cap plus Now, differentiating this whole term with respect to y. Similarly, go with term by term. Differentiation of x square with respect to y is 0. Because if we don't have anything, we represent it as x square can be represented as x square into 1. X square remains constant. Differentiation of 1 with respect to any variable is 0. 0 into anything is 0. So, we define that as 0. That's it. Now, plus differentiation of y square with respect to y is 2y plus differentiation of z square with respect to y is 0 minus differentiation of constant 0 plus now differentiate this whole term with respect to z, differentiation of x square with respect to z 0 plus differentiation of y square with respect to z 0 plus differentiation of z square with respect to z 2z minus differentiation of constant 0 with respect to j cap with respect to k cap. That is gradient phi1 which is equal to 2x I cap plus 2y j cap plus 2z k cap. This is our gradient phi, but they have given at some point, that is 2 comma minus 1 comma 2, that is at the point 2 comma minus 1 comma 2 where x equal to 2, y equal to minus 1, z equal to 2. That is gradient phi1 which is equal to 2 into 2 I cap plus 2 into minus 1 j cap plus 2 into 2 k cap. That is gradient phi1 which is equal to 4 I cap minus 2 j cap plus 4 k cap. This is our gradient phi1. See, we have find gradient phi1. Now let us find modulus of gradient phi1. Modulus of gradient phi1 represents square root of the values, that is 4 square plus minus 2 the whole square plus 4 square. Use the calculator so that you will get the solution with respect to directly. Let us use the calculator, that is square root of 4 square plus of use the bracket minus 2 square plus 4 square, you get 6. The value is 6. Now this is the modulus of gradient phi, but what we are going to represent, we are going to represent n1 cap, where n1 cap represent gradient phi1 divided by modulus of gradient phi1. That is, what is gradient phi1? We have 4i cap minus 2j cap plus 4k cap divided by 6. That is modulus of gradient phi1 is 6. So n1 cap, if I take 2 common, that is 2 into 2 I cap minus j cap plus 2 k cap divided by 6. 2 ones are 2 threes are, that is n1 cap becomes 2 I cap minus j cap plus 2 k cap divided by 3. This is the required first unit normal vector with respect to n1. Now, similarly, I need to find n2 with respect to the another scalar function, that is x square y square minus z minus 3. Now, consider n2 cap which is equal to gradient phi2 divided by modulus of gradient phi2. Done? Yes. Now let us go with this step by step. What is gradient phi2 defines? Gradient phi2. First, let us represent phi2. That is phi2 which is equal to x square plus y square minus z minus 3. Gradient phi2 defines dou phi2 by dou x plus dou phi2 by dou x I cap plus dou phi2 by dou y j cap plus dou phi2 by dou z k cap. That means I need to differentiate this scalar function phi with respect to x, y and z. That is phi2 which is equal to dou by dou x into what is phi2? We have x square plus y square minus z minus 3 into I cap plus dou by dou y into x square plus y square minus z minus 3 j cap plus dou by dou z into x square plus y square minus z minus 3 into k cap. Now I need to differentiate with respect to x, y, z. That is okay. I need to differentiate this whole term with respect to x, y, and z. That is gradient phi 2, which is equal to. First, let us differentiate term by term. In this first term, we have x square, so I can differentiate. That is differentiation of x square 2x. Differentiation of y square with respect to x is 0 plus differentiation of z with respect to x is 0 constant 0 into I cap plus now with respect to y x square with respect to y 0 2y sorry y square with respect to y 2y minus differentiation of z with respect to y 0 minus constant 0 into j cap plus differentiation of x square with respect to z 0 y square with respect to z 0 minus differentiation of z with respect to z is 1 minus constant again it is 0. You get k cap where gradient phi 2 which is equal to 2x I cap plus 2y j cap plus of minus 1 k cap. If we represent gradient phi 2 which is equal to 2x I cap plus 2y j cap minus 1 k cap. This is our gradient phi 2. Now for this gradient phi 2 we are going to apply the what at the point 2 minus 1 2, that is that is at the point 2 minus 1 2 where x equal to 2 y equal to minus 1 z equal to 2, just apply that is gradient phi 2 which is equal to 2 what is x 2 I cap plus 2 into minus 1 j cap plus not plus again minus 1k remains constant since we don't have any value to apply, it becomes 1k cap. That is phi 2 which is equal to 2 2s are 4 I cap minus 2 j cap minus 1 k cap. This is the value of gradient phi 2. Now I need to find modulus of gradient phi 2. Modulus of gradient phi 2 defines square root of this, that is 4 square root of 4 square plus of minus 2 whole square plus of minus 1 the whole square. Use the calculator so that you will get the solution directly. That is square root of 4 square plus of minus 2 whole square plus of minus 1 the whole square. You get root 21. Square root of root 21. This is gradient phi 2. Now unit normal vector of n2 which is equal to gradient phi 2 divided by modulus of gradient phi 2. That is what is gradient phi 2? We have 4 I cap minus 2 j cap minus 1 k cap divided by square root of 21. This is the unit normal vector of another scalar function, so that is with respect to phi 2. Now I need to find the angle. To find the angle, that is, now what we are going to do? To find the angle, we are going to consider that is cos theta which is equal to n1 cap into n2 cap. What is n1 cap represent? N1 cap represent gradient phi1 divided by modulus of gradient phi1 into gradient phi2 divided by modulus of gradient phi2. Cos theta which is equal to what is gradient phi1? Gradient phi1 we have 2 I cap minus j cap plus 2 k cap divided by 3 into What is gradient phi 2 divided by modulus of gradient phi 2? We have 4 I cap minus 2 j cap minus 1 k cap divided by root 21. Just multiply numerator and denominator. Cos theta, which is equal to 2 into 4, 4 2s are 8. I into I, 1, minus into minus, plus 1 into 2, 2, j into j, 1, plus into minus, again minus 2 into 1, 2, k into k into k, 1 whole divided by 3 root 21, plus 2 minus 2 get cancelled. Cos theta, which is equal to 8 by 3 root 21. Since I need the angle, theta, which is equal to cos inverse of 8 by 3 root 21. This is our required solution for the given angle between the surface at the two scalar function at the point 2 comma minus 1 comma 2. I hope you have understood this problem. For more videos, please do like, share and subscribe. See you in the next video. Thank you.